Good morning, students. Now let us begin the second chapter of Algebra, Real Numbers. Now in lower classes, we have learned about the different sets of numbers, that is the set of natural numbers, the set of integers, and the set of real numbers. Now let us again recall about these different sets of numbers. Now first let us see about the set of natural numbers. The set of natural numbers is denoted by n. The natural number begins with 1. So 1, 2, 3, 4 and so on is the set of natural numbers, and this set of natural numbers is infinite. So when we include 0 in this set of natural numbers, then that becomes the set of whole numbers. Now the set of whole numbers, you can see here, it is denoted by W, and it is also an infinite set of numbers. Now when the negative integers -1, -2, -3, -4 and so on, they are added to the set of whole numbers, then we get the set of integers. So the set of integers we denote it by I, and you can see here how we write it, dash 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 we put, then -3, -2, -1, then 0, 1, 2, 3. Now after the set of integers, the question arises that if you have a rational, these fractions, if you have, now the fractions, they are also called fractions. Here we denote it of the form p upon q, where p and q both are integers. So where this fraction should be included in which set of numbers? So for that, the set of rational numbers was discovered. So this set of rational numbers, it is denoted by q, and the set of rational numbers is consist of all the integers as well as the fractions. Now these fractions, they are positive as well as negative. Now the set of rational numbers, it is denoted as p upon q, where p and q both are integers and the denominator q is not equal to 0. Now the next comes here, this one R is called as the set of real numbers. Now this set of real numbers, it consists of rational as well as the irrational numbers. Understood? Now in 8th standard, we have studied about the rational numbers as well as the irrational numbers. Again, we will be revising this as we proceed further. So from this different sets of numbers, what we see that the set of natural numbers n is the subset of whole numbers. W is the subset of I, that is the set of integers, because all the whole numbers, they are also the integers. Then integer set I is the subset of Q, that is the set of rational numbers, because all the integers are also the rational numbers, and all the rational numbers, they are also the real numbers. So Q is the subset of R. So this subset relation exists between the different sets of number. N is the subset of W is the subset of I is the subset of Q, and Q is the subset of R. Now next is about the order relation on rational numbers. Now order relation means here, when we are comparing two fractions, then what we do here, we cross multiply. Like here, p upon q and r upon s, these are the fractions. So in order to compare them, what we do, we cross multiply this p upon q and r upon s. So if ps is equal to q into r, then we say that the two fractions p upon q and r upon s, they are equal. Now if p into s is greater than q into r, then the first fraction p upon q is greater than r upon s. And if p into s is less than q into r, then we write down p upon q is less than r upon s. Now next we will see the properties of the this one rational numbers. Properties of the rational numbers, it has this following four properties. Commutative, if ABC are rational numbers, then the first property is commutative property. Commutative property, it means what? If a plus b is equal to b plus a. So when you are adding the two rational numbers, you can add them in any order. Then associative property, if you are adding three rational numbers, then you can first add the two rational numbers a and b and add the third one to that sum, or take the sum of the second and the third rational number and add the first one to it. The next is your third property is of identity. Identity means here if 0 is added to any of the number, the sum remains same. Means a plus 0 is equal to 0 plus a is equal to a. Then inverse property is here. If the number and its opposite, if they are added, then we get the sum equal to 0. Now, after this here, let us recall again that we know there are two types of rational numbers. They can be either terminating or non-terminating recurring type. Now, terminating type of numbers means what? Here, like this C of two decimal form of numbers means what? This 2 upon 5. This is a fraction. So when you find out the decimal form of this 2 upon 5, means when you divide 2 by 5, what you get? 0.4 you get. Here the division comes to an end. And so this 2 upon 5, this decimal form is 0.4. So this type of terminating type of decimal form is called as terminating type of decimal form because the division has come to an end. Now minus 7 upon 64. So when again the decimal form of this, if you find out, you get it minus 0.10937.5. So here also after certain steps the division comes to an end. We get the remainder 0, and so this decimal form 0.109375, this is also called as the terminating type of decimal form. So here the third example 101 upon 8. So this is also equal to what? 12.625 we get. So this also is an example of the terminating type of decimal forms. So what do we observe in these three decimal forms? See here the denominators are what? 5, 64 and 8. So when you find out the prime factors of these denominators, you will see that here for prime factor of 5 is 5. Prime factors of 64 is what? 2 into 2 into 2 into 2. You multiply how many times? 6 times. So there, what is the what is the prime factor there? Again 2. Then 8, it is what? 2 into 2 into 2. So here in this terminating type of decimal forms, we see that in all these fractions here, the denominators there, the prime factors are either 2 or 5. So in general, we can say that whenever the prime factors of the denominators of the fractions, if it is 2 or 5, then the decimal form of that fraction, it is a terminating type of decimal form. Now let us see this non-terminating recurring type decimal forms. Now here in this example, you see first one 17 upon 36, the decimal form of it you find out. So you will get it 0.472222 and dash 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 is there. This means what here? There you keep on getting the quotient 2 to 2 and also the division does not come to an end. So this type of decimal form of the number, this is called as the non-terminating recurring type. So what is the decimal form here now? 0.472 recurring. Now second, so now here see the prime factors of 36 is how much? Here 2 into 2 into 3 into 3. So in the denominator here of this denominator 36, if you find out the prime factors, then what we get here? We get there as 2 and 3 are the prime factors of this 36. Then 33 upon 26. Again you find out the decimal form of this. How much you get? 0.2692307 So what we observe here, it is that this group of digits 692301, this group of 6 digits, it is repeated. So what is the decimal form of this? Again, if you continue the division, what you will observe? The division will not come to an end, and also this group of digits 692307 will be repeated. So the decimal form of this 33 upon 26. Again it is how much? 1.26923007 recurring. Understood? So what is the prime factor of this 26 now? 2 into 13. So 13 is there. So here in this example also, the decimal form is what now? Non-terminating recurring type. Now third one, 56 upon 37. Find out the decimal form of this. You get it 1.513, 513, 513. So the group of digits 513 is repeated. So this 513 recurring, this is also what? Non-terminating type of decimal form. Now the 37, this is a prime factor, prime number. So its factor will be what again? 37 only. So what we understand from here, this one in general here. So what you have to remember from this examples here, that if the prime factors of the denominators, if it is 2 or 5, then the decimal form is a terminating type of decimal form. If it is not 2 or 5, then the decimal form, it is non-terminating type of recurring form. So in this way we can understand this in short. Now let us see the practice set 2.1. Now in this 2.1, the first question is classify the decimal form of the given rational numbers into terminating and non-terminating type. Now as I told you earlier, how you will classify without solving this one? Just you find out whether the prime factors of the denominator, if it consists of the prime factors 2 and 5, then it is a terminating type of decimal form. If it is some other number besides 2 and 5, then the decimal form is non-terminating type. Now the first one, 3 upon 5, that is 5. The prime factor of 5 here of the denominator is 5. So it is a terminating type of decimal form. Now second one is 2 upon 11. So again there the prime here, this will 2 upon 11 is there. So it will be what? Non-terminating type. Then 29 upon 16. Prime factors of 16 is what? 2 here to multiply how many times? 4 times. 2 into 2 into 2 into 2. So this will be a terminating type of decimal form. Then 17 upon 125. Prime factors of 125 is what? 5 into 5 into 5. So again, what's the answer there? The decimal form is what? Non-terminating. Decimal form will be terminating type. Then 11 upon 6, the prime factors of 6 is what? 2 into 3. So the decimal form will be what? This one, decimal form will be non-terminating type. So this, from these examples here, what we can say? 13 upon 5, 29 upon 16, 17 upon 125, these are the terminating type of decimal forms, because the denominators are prime factors either 2 or 5. Then 2 upon 11, 11 upon 6 are non-terminating type recurring form, because their denominators are other than prime factors 2 or 5. Now the next question is here, solve the following in the decimal form. 127 upon 200. Just divide this 127 upon 200. So here you will get the answer 0.635. As the normal division which you have learnt in the lower classes, that we only have to perform the division. Then second one is here 25 upon 99. So divide to 25 upon 99. Find out the decimal form. The decimal form is what here? 0.25. So you'll keep on getting 25 here 0.25. So here the answer will be 25 will be the recurring one. Then 23 upon 7. Divide 23 by 7. So answer is 3.285714. So here this is again, it will be repeated. So 23 upon 7 is 3.285714. Then 4 upon 5. So divide 4 upon 5, the answer is 0.8. Then 17 upon 8. 17 divided by 8 you do, you will get the answer 2.125. So this is a terminating type of decimal form.